Okay, so this lesson is the last lesson in Unit 4, and this concerns arithmetic sequences. So the patterns we talk about in this lesson really follow the patterns we've been talking about this whole unit. So the basic idea of an arithmetic sequence is a list of numbers that follows a pattern where to get the next term in the sequence, you are adding the same number each time. Now, the values in the sequence can go up or they can go down. If the values are increasing, that means we're adding a positive number. If the values are decreasing, that means we're adding a negative number. So in example 1, if we are describing the pattern in each of these sequences for part A, I would describe this pattern as my first term is 5. I'm just going to write first term is 5. And you add 3 to get your next term. That's how I would describe that. Start with 5, and you add 3 to get to the next term. So if I was finding the next two terms in the sequence, if it's adding 3 to get to the next term, 14 plus 3 is 17. 17 plus 3 is 20. So simple as that. Now, in the next one, I've got 2.5, 5, 10, 20. Now, this one, first term is 2.5, and then to get the next term, we're not adding a number. To get next term, we multiply by 2 to get that next term. So my next two terms, 20 times 2 is 40, 40 times 2 is 80. So for these two examples, I'm going to outright say, part A, this is arithmetic. This is an arithmetic sequence. It's increasing by addition. Okay? The second one, first term is 2.5. It's multiplying by 2. This is not arithmetic, and we will get to what type of sequence that is later on in the year. Okay? So I'm going to jump right to the next example, and that's identifying arithmetic sequences. So arithmetic sequences are sequences that add or subtract the same number to get the next term. So 3, 8, 13, 18, plus 5, plus 5, plus 5. This is arithmetic. Okay. And our common difference, I'm going to use the letter D as a variable to represent our common difference. In this arithmetic sequence, our common difference is 5. If it were decreasing by 5, the common difference would be negative 5. Our next example, plus 3, plus 4, plus 4. Now, I get that it's increasing by addition, but it's not increasing by the same common difference to get the next term. So this is not arithmetic. So it doesn't have a common difference if it's not arithmetic. So that's an important distinction to make. They can be increasing by addition, but they have to increase by adding the same number to each term.